Hello, everybody. I am teacher Melaku and I'm biology teacher at SOS Romano School. I have been teaching this subject biology for the last 20 plus years. And today we shall talk about biology grade 12, unit 3, which talks about energy transformation, which is thermodynamics in living systems, of course. Now, before I directly talk about energy transformation process, I have to talk about these two organs: energy translation organs. Organelles for energy translation organelles. These two organelles are the first to be discussed is mitochondria. And the second organ in eukaryotic cells, which is used to transform energy, is chloroplast, of course. These two organs, as far as eukaryotic cells are concerned, are involved in energy transformation or transform, and they are taught as thermodynamically suitable organelles. First, we shall talk about mitochondria first. Here, and this organelle energy in the form of sugars like glucose is converted, biochemically converted into energy in the form of immediate energy source, ATP, by which cells use. Every cell uses energy because living cells are involved in complex biochemical processes. It is said that living is work, and work requires energy. That energy is chemical energy, and the immediate source of energy for living cells is adenosine triphosphate, the universal energy currency of living cells. And the second organelle is chloroplast, of course. These two organelles are very much sister organelles. They are similar in many aspects. The second is chloroplast. The second is chloroplast. Chloroplast. What was the preparation? Okay, chloroplast. Chloroplast, what occurs in chloroplast? Chloroplasts synthesize sugars from inorganic molecules like carbon dioxide and water. These are converted into glucose, C6H12O6. This is energy by itself. Glucose is energy, chemical energy. Therefore, this organelle is simply involved in transforming or changing the energy of the sun by using special pigment molecules like chlorophyll, and not only chlorophyll, of course, accessory pigments into sugar molecule. Plus, of course, photosynthesis also produces oxygen, not only production of glucose. The process of photosynthesis also contributes oxygen to the atmosphere for aerobic organisms. Therefore, first we start from mitochondria. What happens in glucose molecule in mitochondria? Then I will discuss about the metabolic pathways that are involved in aerobic respiration. When it comes to energy production, mitochondria, energy transformation, in the mitochondria. This one talks about aerobic respiration. Aerobic respiration. In the presence of oxygen. Aerobic respiration that occurs in the mitochondria in the presence of oxygen. That means it requires terminal electron acceptor, which is served by this special molecule, which is about 21%. Therefore, aerobic respiration that occurs in the mitochondria begins the pathway from these pathways, reactions, in aerobic respiration can be divided into four separate or connected reactions. The first is glycolysis. Of course, this pathway is not only for aerobic respiration, it's common pathway for anaerobic respiration also. The second, immediately after glycolysis, if there is oxygen, there is the process that happens in the mitochondria that is known as link reaction. Then after link reaction, of course, this is not pathway. Pathway means series of biochemical reactions, stepwise biochemical reactions that are each step catalyzed by specific enzyme. The third is a central metabolic pathway which is known as citric acid cycle. Citric acid cycle. And immediately after citric acid cycles, there are these coenzymes. These coenzymes, NADH and FADH2, give the energetic electrons by dropping the protons in the matrix of the mitochondria in order to generate huge amount of energy by the process known as oxidative phosphorylation plus heliosmosis. I will explain everything about this process. The process is also known as oxidative phosphorylation, which happens in the electron transport chain. It's not Ethiopian telecommunication, please, it seems. Electron transport chain. I will explain what electron transport chain is and what happens there by starting from glycolysis, the first pathway. I really love to talk about glycolysis because it is the first involvement. The first stage of aerobic respiration is glycolysis. Now, what can we say before I describe the stepwise chemical reactions that happen in glycolysis? I'd like to say a few words about this special type of biochemical pathway. This pathway is a 10-step pathway. 10 steps are involved here. It's pathway. As I've tried to describe earlier, a pathway is a series of biochemical reactions, stepwise biochemical reaction, each step being catalyzed by specific enzyme. Therefore, this is pathway. Sometimes it's also known as glycolytic pathway. 10 steps, pathway, glycolytic pathway, or simply glycolysis. The first evolved in terms of evolution of biochemical processes, it is thought that this pathway evolved in the ancient anaerobic world when the first prokaryotic cells began to evolve the first. Therefore, it is thought that the most ancient biochemical pathway, and it is ancient, which means first evolved energy transaction or energy transformation. Energy transformation. Pathway, first evolved energy transformation pathway in the ancient anaerobic world. Then, what can you say? Of course, in terms of its efficiency in terms of energy production, it's not that much efficient. So, of course, it is inefficient. With almost efficiency of between 2 to 3% efficiency in terms of energy, extracting energy in the form of ATP from glucose. Highly inefficient, we can say even highly inefficient pathway. And it is also universal, which means it occurs almost in every living organism. As far as biology is concerned, every living organism. This tells that this is our common origin pathway. Still, we use it. Still, aerobic organisms use it as the beginning pathway in aerobic respiration. Therefore, it is common pathway. Common pathway for both aerobic and anaerobic breakdown of glucose. It's common pathway, starting pathway. By itself, it doesn't require oxygen. But when there is oxygen after glycolysis, aerobic process proceeds. Aerobic process continues in mitochondria. And therefore, first, I will show you what happens after glycolysis in cells which are deprived of oxygen. That means the